Okay, so I'm just going to do a brief overview of what it's like to design a part. What I've done is I've sketched up on just paper and pen some dimensions from the existing part, and I will be creating the geometry and software in Fusion 360 to model that part so that we can create tool paths to cut it. So the first thing we're going to do is start with some stock. I know that we're 0.775 inches tall. Like that. Alright, and then what I like to do is just kind of get a rough drawing of everything. Yeah, I forgot a little. Then what I typically do is come back and dimension it all. So we know that this is let's make those lines collinear. right. Okay, and now we've got a fully defined sketch geometry. So what we'll do now is we'll save that, finish the sketch. Come over here and we're going to revolve it. Okay, select that as the axis and boom. Alright, so this is the rough shape, but we've got a little bit of work left to do on it. Tangent. Let's trim this up some. Make this tangent. That looks good. Alright, so that's all. When it's black, it means that it's fully defined. Let's create a circular pattern. Yeah, that looks right. We can come in here and... Alright, I think that's going to give us what we need. Extrude cut that through all. Alright, so now we pretty much have a rough shape of what we want. Alright. Okay, so let's save that. Good. Alright, and then we will pause this briefly and get some water. Well, that was unfortunate. I thought I had hit the record button, and apparently I did not while I was doing the cam processing. Well, quickly what I'll do is I'll walk you through what I did. Sorry about that. It probably would have been a little bit long. It usually takes me about 45 minutes to an hour to go through and cam everything, because you really got to be careful what you're doing. You know, machines are not smart. They're only as smart as the person that's entering the information. So you got to really cross your T's and dot your I's. Alright, so we got 3 setups on 3 different machines. The first is going to be roughing out this part, and we're going to use the Harding Cobra 42 slant bed lathe. It's just quick and easy, especially from removing heavy material. So essentially this is going to come through. We'll do a kind of representation. We'll walk through each one. We can speed that up a little bit. Essentially just roughing the part out. And then we're going to do a finish pass, which is, well, I'll tell you what. Why don't we just do the whole setup there? Alright, so this is just roughing out the material, getting to the rough shape. Pretty boilerplate. That's the finishing pass. That took it down to spec. Now we're doing some grooving to get the backside and parting. And what we're left with is this piece here. So then what we do is we're going to go to the mill and I'm going to have to find a way to hold this part. This is actually, it's quite small, you know, it's only 1/4 of an inch. And these two are not the same diameter. This inner one is a smaller diameter to clear a step inside of the pocket that it fits in. So we're really only grabbing $80 thousandths. So you can imagine that's not a whole lot. We have to machine on this, which applies a lot of upwards force from the helix of the cutting tools. So we'll have to make some fancy fixturing. Just quick and easy, something that'll hold it good. Alright, so what we'll do is I'll walk you through what that machining process will look like. Now, actually I guess what we'll do is we're going to have to speed through. Alright, and then we'll be taking it off of the lathe. And so now we're going to go over to the mill. I'll profile that out. I'm going to drill that hole. Now we're boring out that first hole, and we're going to take that down in 2 steps. We're going to do a rough pass, and then we're going to do a 5 thousandths finish cleanup, just to make sure we get the right diameter for the thread OD. And there we go. Let's just see if we can speed that up a little bit. Sometimes when I play with it there, we're just taking these out to the final dimension by boring. Now we're just setting a chamfer. Now we're going to chamfer the, alright. Now we're threading. This is thread milling, which is really fun to watch. I don't know how much you'll be able to see with the flood coolant on. And at last we were just taking a little nip on that. So, and then we've got to take over to Well, having some technical difficulties there. Let's see if we can do that again. In case you're wondering, this is extremely graphics heavy, and my PC is getting a little bit on the older side. Probably going to have to upgrade shortly. Well, there you go. So, what it didn't show was the last operation, but it showed the result. You're probably bored by watching all that by now. But anyhow, what we got here is the finished product. This is just cutaway stock, but this is now a very fine replica of the piece that was in need of repair. So now let's take it out to the machine. We'll send all this out there, and we will make parts. It looks like we're in for about, I don't know, 35 minutes or so of machine work, plus setup and some other stuff. It's just not too bad. Probably have about 45 minutes in the total. All right, well, let's head out there and do that.
Well, there's not really a great way to get this all on film. Anyways, I will cut back over when I've got the finish. Oh, that's not too bad there. All right. Okay, so here's the original piece, and it's a fine piece. It's made out of a very soft material, though. And if we look inside the boss, you can see that the threads are not in great shape. Unfortunately, there's not really enough meat to repair this properly, in my opinion. So we're going to make a replacement. So the replacement, I've already turned the rough shape on the lathe. You can see here. And obviously this has to be machined out, and that's what we're getting ready to do. You can see everything is pretty much identical here, except for the few holes in the threaded section in the middle of the boss. So how do we hold this? It's tricky, right? The easiest way is to machining a fixture. So in here, I've got 2 small pieces of aluminum, and I put 5/1000 shim between them. And what I'm going to do is machine a pocket and a relief around the edges, so that when it's finished, I can drop this down in, clamp the vise with that out, and it should hold this flat in place. So we're getting ready to machine this, and we'll see how that goes. All right. So here on the screen you can see we have, this is the tool path that we're getting ready to use. We'll be using tools 5, 22, and 48, which I've already set up and loaded in the machine in the ATC. I've already zeroed the work coordinates, and we're getting ready to start it up. Kind of hard to see what's going on with all the flood coolant, but Alright, so that's probably about all we'll get now that face mill is on there. Let's try maybe over here. Now we're just going to chamfer the edge on the internal pocket. That'll give the radius on the new part. Alright, let's see what we got. Okay. Might have to go a little bit more on that radius, or on that chamfer. Everything else though looks great. Let's see if she fits. Nope. So I think that's going to be pretty much perfect. It won't go in right now because it's a very tight fit so that it captures it when we do put it in. But you can see that the bottom section, which is about 5 thousandths smaller, it fits in there. And it's got about 5 thousandths play. So the new piece, when we separate it, it should go in perfect. But I'm gonna add another 10 thou of chamfer there to account for the fillet that's here from the lathe tool. Alright. Okay, so we've now updated the program. We're just going to use just this tool and make one more pass and take that to 15 thousandths of a chamfer. Let's see how that does. Much better. Alright, so now it's going to be kind of tricky to do this with one hand, so I'm going to pause it and come back to it when it's loaded. Okay, so this fit in here just perfect. You can see we've got the shim, I don't know if you can see that, at the bottom, so that'll get a nice tight fit, and that is in there. At least we hope it is, because we're about to machine and we don't want it to pull out. So the next step is going to be to probe the center here. This is our work offset. So we'll pause here and get the probe set up and make that happen. Okay, so we've got the probe set up, and I'm going to come over here. We're going to use the probe center point operation. We've got our hint set up at 0.625. So let's do that. I was finding rough center, now we're going to find fine center. All right, We have now located the center of the part, so we'll pause here and load the program and get to machining. Okay, we're all loaded up. I've got the camera set up outside. I've got it on a stand so it should be a little less shaky. And we're about to hit the start button. I have some fairly conservative feed rates just because we're only grabbing that part by about 30 thousandths of an inch worth of material. And there's a lot of up force that's created by the helix of the cutter. With a little luck, this should hold in place and give us our nice finished part. Alright, we'll have a tool change. Drilled our holes. Now we're going to bore. We're going to take it to a rough size, and then which will leave 5 thousandths of an inch on the wall, and then we'll bore it to final size before threading. Now we're going to take it down to final size. Now we're piloting out and boring the holes to the correct size for the screws. Now we're going to chamfer. This is just to put an edge brake on it. Now we're threading. And now we're going to final chamfer the edge. All right, I'm going to take you out of the holster now. Whoop. Sorry about that. All right, so this is now the new part. I'm not going to take it out because I've got to test the threads to make sure that the sizing is correct, but there we go. All busted, new billet and shiny. What I'll do is I'll laser on the stamping number so that you'll have that, and then of course you can keep this piece also. I looked to see if this piece could be found online, and I couldn't find it. So I don't know, for those that might have the same issue, send them my way. All right, I'm going to test fit that thread, and as long as everything checks out, we'll take it out and have a look, and should be ready to go on the injection unit. Okay, so we are all machined. I don't know if you can see, I went ahead and engraved the stamping number so they're the same. I have test fit it, it fits perfect. So the O-ring fits perfect, everything fits, all the bolts line up, bolts fit the holes just right. It is a winner. I'm calling this one done. Let's see, yeah. Tried really hard to get the engraving in the exact same spot, but I was off by just a little bit, but I mean, at least it's on there, so. These threads are much better too. I don't know if you can see this, but they are very snug fitting. I went nice and tight so you won't ever have to worry about those stripping again. These were a little bit on the sloppy side, which, you know, back in manufacturing back then was not super perfect. So it's a little bit on the shiny side. I don't know what we can do to gray it up, but luckily it'll be on the underside. So it'll be on the underside there, so I don't think anyone's really going to notice it. But that should work. That should stop the leak. We should be ready to put everything back together. Just put the O-ring back on it and spring back in, and off we go. What I did do, I don't know if you can see, if you can see down in that little hole, there's a series of steps. Let's see, focus. Oh, that's going to be tough to focus. Oh. So let's try that again with the focus. Anyway, you can kind of see there's a step down there, and what that is that's to stop the tube from going too far down. I machined that hole so that it's a near light press fit for the tube itself. And then we're just going to use the bubble flare. We're not even going to use the O-ring anymore. Bubble flare compression fitting is a lot better than an O-ring. That way you don't ever have to worry about the O-ring dissolving. So this should be a much, much better fit than what was on there before. No leaks. And, you know, obviously the coloring issue, but like I said, I don't think anyone's going to really notice it. On the bottom. So there you go. Project finished. We'll get this put back together and we'll see if we can get that Corvette fired up. All right, Mr. Hull, thanks.